Okay, I'm glad to introduce Professor Sylvia Osborn from the Department of Computer Sciences at the University of Western Ontario. Professor Osborn has done a lot of influential research in the area of role-based access control and database security.
Okay, thank you very much, Elisa, and good afternoon, everyone. So the outline of my talk today is I'll spend a fair bit of time talking about the role graph model, which is our version of role-based access control, or RBAC, and the differences between our model and the Nist ANSI standard model. And then I'll look at, again, mapping from discretionary access control to roles, and then I'll have a few comments about delegation and a few comments about the future of RBAC. So the beginning of role-based access control, actually if you Google role-based access control, you'll come up with 3 papers from the 1980s. Some of these papers actually have all the concepts there, but people didn't really pay much attention to it. This tends to happen in I think in computer science research, good ideas get reinvented every 10 or 15 years. And then if you move into the early 90s, we see some early papers by Ferriolo and Kuhn from Nist. My PhD student, Matunda Nyanchama, and I, and Ravi Sandhu and some of his colleagues. And these are the real important introductions to RBAC, which have carried on. The earlier papers, the ideas sort of got overlooked. Okay, so what is our role graph model? So as Nyanchama envisioned it right at the beginning, he talked about it being on 3 planes. So we'll start with the middle. And in the middle we have the role graph, or role hierarchy. A role is defined as it has a name and a set of privileges or permissions. Some people say permissions, some people say privileges. It means the same thing. A privilege is a object access mode pair. And we have edges in the role graph whenever we consider one of the roles to be junior to another role. It means all of the privileges of the junior role are contained in the senior role. And we actually distinguish between direct privileges, which are those that are assigned to a role by the administrator of the system, and the effective privileges, which includes the direct and all the inherited privileges. Privileges, again, consist of an access mode object pair. Both of these components can have some kind of structure. So the object could be a big complex automobile design in an object-oriented database. It could be a single value in a relational table. It could be an XML document. And there was some early work on object-oriented database security by Elisa and some of her colleagues, where they examined how permissions can propagate either because of the access mode or because of the object structure. And so if you think of an XML document, it's basically a tree. And if you have a permission, say, to read that starts partway down, so this thing here is meant to represent an XML document. If your permission to read starts here, it would propagate to all the sub-elements in the XML document. Now on the left-hand plane, we have something we call the group graph. And we define a group as a collection of users, full stop. And so you can create groups just because it's handy to have them to assign to roles. So here in this example, we have this admissions committee. It has some university employees, and it has a student. And they're on that committee because they belong, for whatever reason, in the real world. And if we represent that as a group, then we can assign it in one operation to all the permissions of the admissions role over here. So we haven't actually drawn the user role assignments on this picture. And then So I've talked about the 3 planes, and so then we have the relationship between privileges and roles, which gives you the privilege role assignment and the user role assignment. And you can also create groups, maybe according to some qualifications that people have. So you might have a group for accountants, and the basis of belonging to that group is just that that you have, the appropriate qualifications, and it has nothing to do with anything that you're actually performing at the moment. It just has to do with you as a user. Okay, so again, very early on, we started talking about algorithms, and we ended up with 2 role insertion algorithms. The first one was the one that Matunda had originally, and the parameters are that you have a given role with its name, its direct privileges, the other roles that you expect to be its juniors, and the roles that you expect to be its seniors. We require that the role graph be acyclic. So in all of our algorithms, if we're about to create a cycle, we just abort and return to the previous version of the graph. And when we're done with the algorithms, we clean up. So you may have thought something was a direct privilege, but by specifying a junior, it ends up being an inherited privilege. And so we change the representation of the privilege. And we actually insert extra edges if we discover that there are 2 roles in the graph such that one of them permissions are a proper subset of the other one. And I'll try and explain why we did that in a minute when we look at an example. So if you're going to have duplicate roles, this will oblige you to create a cycle which violates it being acyclic. So basically, we don't allow roles with duplicate privilege sets. And in the second role insertion algorithm, you just give the role with its effective privileges, and the algorithm does all the work for you. It figures out where it belongs in the graph and where the edges go. All right, so here's an example of the first algorithm. So we want to add an instructor role. And the result of that is, so we've thought that counselor will be a junior, and we've thought that admissions would be a senior. And so the algorithm draws the brown edges that are there. Sorry, the brown edges are given. The algorithm also notices that, so what I've shown here is the role name and the effective privileges I've just represented by numbers. So the instructor has permissions 1, 2, and 3, which is a proper subset of the privileges of the dean role. And so we draw an edge there. And why do we do that? Well, we decided right at the very beginning that because the dean role contains all the privileges of the instructor role, we should show you that by inserting this role, if you assign someone to the dean role, they can effectively perform the instructor role. So why not give that as feedback to the user who's designing the role graph? And this has consequences, as we'll see later. And it's really the main way in which we differ from the ANSI model. Now, if we want to start with the original graph again and insert a role senior counselor with 3, 5, 6 as direct, counselor as junior, we end up inheriting 1, 2, which gives us the same privilege set as the dean. And so we would reject this operation because it creates a duplicate role. And we would be obliged to insert the edges that would create a cycle, and then it wouldn't be acyclic. Okay. An example of the second role insertion algorithm. You just give the effective permissions, and the algorithm figures out where it goes in the graph. This is the one actually that people prefer to use because it's a little less work. But, okay. So we have other algorithms, insertion and deletion of a privilege to or from a role, adding and deleting edges. I also did a little piece of work on merging 2 role graphs, so vaguely related to database integration. So suppose you're integrating 2 databases and you have their access control information represented by role graphs, then you can merge the two role graphs when you merge the two databases. Okay, and so they all do what we call restoring the role graph properties. And the main thing there is that they may add edges. And they all abort if we would create a cycle. And we actually discussed conflict of interest, which other people call separation of duty. Now, the model that Sandhu and his colleagues came up with ended up being indistinguishable from the Nist model. And here is a fairly common representation of that model. So you can see it has all the same components, just drawn slightly differently. So we have roles, we have a role hierarchy. Permissions are represented by operations and objects together. And the new thing here is the fact that they have sessions. And sessions are there to represent the roles that a user has activated when they're actually logged in. And so the ANSI RBAC standard comes in 4 flavors. So there's what they call core RBAC, which has no role hierarchy. And I believe they left that in there because there are some commercial products that are like that, and they wanted the standard to apply to anything out there that was calling itself RBAC. Hierarchical RBAC has a role hierarchy. Constrained RBAC has separation of duty constraints, and then the 4th one has both hierarchical role hierarchy and constraints. The most common constraints that people talk about are static separation of duty, which applies to the user role assignment, and it says that when 2 roles are in static separation of duty relationship, that they should not appear in a single user's user role assignment. So the same user should never be able to use those 2 roles. Dynamic separation of duty applies to role activation. So you can have both roles in your user role assignment, you're just not allowed to activate them both at the same time. So this, they actually both talk about the role hierarchy because you're looking at the pairs of roles. So that's where those fit in. So the major differences between the 2 models, we didn't have sessions. They didn't have groups. And we had this thing called max role, which we were going to get rid of, and then we found a good use for it, which I'll show you in a few minutes. We have these side effects where we actually insert edges when we discover that the effective privileges of one role are a proper subset of those of another. We actually, so this implication is in both directions. We actually insert an edge. Whereas in the ANSI model, the implication is only in one direction, and you can actually have roles with equal privilege sets. Because they don't put in edges, it doesn't create cycles, right? Whereas for us, so they also require that their role hierarchies are acyclic. Okay, so with the ANSI model then, going back to the first example, the ANSI model actually wouldn't have a max role, so it would look like that. And the operations are in the given by the standard. You actually have to do 3 operations here. First you add the role, and then you add the 2 edges one at a time. And so you end up with this role hierarchy. And so we would have put an edge in here, right? So here's the contrast. And so we can say then that the ANSI model could be described as edges take precedence, whereas our model could be described as permissions take precedence. So
Sylvia, can I ask you a question?
Yeah.
So actually, it seems that I've found 2 different views of what roles are. So some people talk about functional roles, which are the one of the ANSI standard, but which those roles are the ones defined according to the functions of the organization. Mm-hmm. And so two different roles can have the same set of permissions without having any edge. Then there are people talking about application roles, which they refer to as a set of permissions.
Right.
So which one of the two semantics did you adopt in the RGM model?
So what are functional roles again?
Oh, those are the ones stated about the organizational structure of the organization, like a secretary.
And so you could have the same permissions.
Yeah.
And yeah.
Yeah.
In our case, I mean, if you really want two separate roles, you can put in a dummy permission to make them unique if you really want to. Yeah. The ANSI model also has these roles which have no additional permissions, but only users assigned to them. And again, we can't do this because we'd be obliged to put a cycle there. And so that's really how they deal with groups, and I think it's better to have the groups modeled with a separate structure. Okay, so just again then to show what can happen with only two operations. So if we take this top left ANSI diagram and add permissions 3 and 4 to the counselor role, we see they get propagated up the graph and nothing too exciting happens. On the role graph model side, we can't do that because the counselor role ends up with the same effective privileges as the instructor role, and we'd be obliged to draw a cycle. And so we would reject the addition. All right. Now, if we look at just inserting one of those two permissions into the counselor role, the role graph model can handle that, but then we discover that the financial aid role is a proper subset of it, so we draw that red edge in the bottom right of the picture. And I guess I should have deleted this edge here, but that's fine. And then what happens is, suppose I add another permission, say 12, to financial aid. Well, in the ANSI version, it's only going to be in the financial aid role and the admissions role, whereas over here it's going to be in all of these roles because they're all senior. And so in very few operations, the graph that you have, the role hierarchy, differs quite a lot. And my overall comment on it is I don't necessarily think one is better than the other. They're just different, and as long as you have good tools that give you feedback and you see what's going on, you can design the role hierarchy you want under either set of assumptions. So very early on, people were claiming that RBAC was general enough to simulate both mandatory access control and discretionary access control. Before you can talk about DAC, you need to talk about administrative roles, which I'll do in a minute. For MAC, the mapping is actually quite simple. If we have a lattice of security labels, which we have on the top left there, to simulate this with the liberal star property, which allows you to write up and read down, what you do is you reproduce the lattice with reading roles. You reproduce it upside down with writing roles, and then you put on constraints that says, say an M1 user comes along, when they try to activate any roles, they must have both M1 read and M1 write activated at the same time, and so that allows them to both read the low data and write the high data. Okay. For the strict star property, you just sort of create these little writing roles above each role. So the strict star property says if you're an M1 user, you can only write to M1, you can't write to any other levels. So if you're an M1 user on this role hierarchy, you'd be assigned to the M1 write role, which you inherit the M1 reading permissions and the low reading permissions. Okay? So those mappings are pretty simple. At around I don't know how long ago now it was, but anyway, for a while ago, I tried to look at converting from RBAC to MAC. So the idea I had was, well, suppose you have an RBAC system. Is there a way to test whether or not it's equivalent to some MAC system. And so what I did was analyze information flow. And so you take each operation, you look to see if it's a reading kind of a thing or a writing thing or maybe both. If it's an update, you have to split it. And then you draw the information flows that result. And the crucial thing here is that when you're assigned a role, you get all the permissions. There's no leeway there. It comes as a unit. And so you end up with a graph that shows where information flows are possible. You collapse cycles because the things in a cycle, they flow to each other, so they're going to end up with the same label if you're going to label things. Now, you don't always get a lattice. Not every acyclic graph is a lattice. Okay? And so if it is a lattice, you're done. If it's not a lattice, well, you can just say this is the information flow, or you can fool around with it a bit and try and turn it into a lattice by collapsing some of the roles together. So, I mean, as a, you could collapse everything to one role, and it's, you know, it would be a lattice, but it wouldn't be very interesting. So, anyhow, so that's, I never really finished that little bit about trying to figure out how to convert it into a lattice when you end up with the information flows that don't happen to be a lattice. So moving on then to simulating DAC. So we have these administrative roles. And what does this actually mean? So this was an original mapping originally that Sandhu and Munawar came up with. So we have the object here with its access mode. And then there's a regular role that contains that privilege. So this is, the blue thing represents a privilege. So you have a regular role that contains the privilege. And then there's an administrative role that allows granting of that privilege. And then there's an ownership role that can grant with grant options, so it can actually create grantors. And so the role hierarchy, then the owner role inherits the granting permissions, the regular permission, and has the owner permissions. And so for every privilege for this version of it, you get 3 roles, which seems like an awful lot of roles to me. So what are some of the extensions we did then to the role graph model? So this example here, we have a role for undergraduate student. And what we would like to do is to assign this group called students to this role here called undergraduate student. Now, the dirty little secret is that what we assign to a role is actually an object access mode pair. It's actually an individual object. And so I guess at Purdue you have at least 40,000 undergraduate students. So you would have to create 40,000 student roles, because each one of them, if they're going to read, if this represents their student record, and you want to represent the fact that students are allowed to look at all of their student records, you would have to have an individual role for each student. So we came up with the idea of parameterized roles. And the idea is that the permissions have parameters which correspond, in this example, to the student ID. And then when a student activates the student role, their student ID is used to only instantiate the role with the privilege that corresponds to their student record. So they get their own version, if you like, of the student role. And so the design of the role graph is very simple, but when it is in use, you get sort of individually tailored role activations. Okay, and so we call this parameterized role. So you can talk about constraints. I mean, there's different ways to model it, but the basic idea comes from here. And it wouldn't help to have some kind of a type system for privileges. I mean, the problem really is that we need some kind of finer-grained constraints on role activation. And we'll use that in a minute for something else. So then the other extension we have is dealing with administration of role hierarchies. So the initial role graph model and the ANSI model and the Sandhu model all assumed centralized administration. So you have one role administrator, role graph creator, whatever. And so in a very, very large organization, this is not realistic to have one person in charge of the whole thing. And so people have come up with these designs for administrative models. Now this one by Crampton and Loizou is, they have these things called administrative scope, and they have these elegant mathematical properties. The consequence of which is that if you add a role here, X, this thing sort of pops out into a different shape. And so that the roles that this PL1 role controls change sort of on the fly. And so my student, Wang, who's going to finish his PhD in a few weeks, came up with, actually this was his master's thesis, an administrative model which is decentralized. So you can have different administrators looking after different parts of the role hierarchy, or the role graph. And the idea of what we call an administrative domain is that the top role in each domain contains all the permissions that any of these roles are allowed to have. And so if you're assigned to the administrative role, so this is the administrator, these roles are administrative roles, and you want to add, say, a sub-role to this US agent here, you can use permissions that are in this part of the graph that you control. Permissions get added into this top role by somebody in a surrounding domain. Now, why do we do that? Because if the administrator here of this distribution domain is allowed to add arbitrary permissions, they get propagated out beyond the region of the graph that he's supposed to be controlling. So,
I have one quick question, which is about the separation of duty constraints.
Right.
So, for example, suppose you want to define a separation of duty between clerk and distribution admin.
Yeah.
Who can define this constraint?
Whoever's administrating a surrounding domain.
Oh,
so
okay.
at the very least, there's always this topmost administrative role.
So yes, to do.
Who controls, so max role, so this was the reason for keeping max role, because it kind of is the, we call this the domain ID, it's the top role in the outermost domain.
But couldn't the two local administrators do this operation jointly rather than going up?
Not the way we've defined
Okay.
it. Yeah. But now going back to that example here where this role X appeared sort of off to the side, if a role X was to appear up here, it would have to be done by somebody who controls the domain that it's in. Now, what we do prohibit is if we had because we add edges whenever we find a subset relationship, we might end up with an edge, say, between one of these roles and the accounting role. And the reason why we don't want that is then somebody can add a permission over here, which ends up affecting a part of the graph that they're not under controlling. And so we prohibit, again, things that upset our view of the world. So we would prohibit. But you can have permissions that are replicated, but as soon as the situation is such that an edge is going to pop up there, we're going to reject that operation and go back to the previous version of the graph. Okay. So having this administrative model, and we also have a delegation model, which I won't have much time to talk about today. The question that I posed to He was, what about discretionary access control? Is it really an administrative function, or is it a delegation function? Because if you look at relational databases, all you get to say is grant and revoke. And when you say grant and revoke, are you designing the system ahead of time, or is the system running and you're just delegating something for the afternoon because somebody's sick? Okay. And so which model So, I mean, the commands that are available to you in something like a relational database are very primitive. And so the challenge was, can we simulate, go back to discretionary access control, can we simulate it with the administrative model without using the delegation model? And so the first thing to recognize is this concept of ownership or control is present in all discretionary models. And the ownership has an administrative flavor to it, okay? At least relational databases, when you grant, you have the possibility of saying with grant option, so you can give somebody also the permission to grant. So we have to deal with ownership and we have to deal with granting. He's looked at DAC with change of ownership, but I won't talk about that today. So I had an older paper where we took a relational database and produced with traditional permissions done with grant and revoke statements, a pre-RBAC relational database. And what we did was create a role for each user with all the permissions that had been granted to them, collapse cycles if they're duplicates, and that was the role graph. Okay. Now, it didn't deal with ownership and it didn't deal with granting. And so partly it was to go back and figure out how to deal with it with this new model, with the administrative domains. So suppose you have this company and there are applications that you're using, but people have their individual files. They have their letters that they're writing and so on. And so each person is the owner of their own files, right? And so potentially every single user is an owner of something, okay? And so again, because the privileges relate to specific objects, this implies that we need an owner role in the administrative part of the graph for every user. So that's clearly not a good solution. So what about parameterized roles? Well, if you keep track of the owner of the object, so for each object you just add another attribute which has either a single owner or a set of owners. When the users activate the owner role, their user ID is used to just, again, instantiate the objects that they have control over with whatever permissions it is that you want to put in this owner role. So, given then that we have a single parameterized owner role instead of an owner role for each user, how do we compare? So what kind of metric do we use to compare this with the previous approach from Sandhu and Munawar? So the upper bound on the number of roles is the number of permissions, or maybe the number of users. So you could argue that, well, the role design may have a longer life than the users who come and go from a company. So we'll focus on the privileges in the role design rather than the users. And it's an upper bound because not every access mode may be relevant for every object. So different kinds of objects have different kinds of access modes. We could just have one role, but that's not very useful. So the right answer is somewhere in between, right? And this is still a controversial area that's still sort of, we were discussing last year at SACMAN. So we've decided to measure the number of roles we end up with divided by the number of permissions or privileges. So the original Sandhu and Munawar construction for general liberal DAC actually adds 4 roles for every permission, which is huge. Okay? Having parameterized owner roles adds 1. So we've got a huge improvement there. Now, how do we deal with granting? When a user gets a permission with grant option, they become a potential grantor. Okay? And so we'll distinguish between grantable permissions and ordinary permissions. And just represent that by a Boolean. And so then we have to deal with, at least for relational databases, this statement from SQL, which has a couple of versions. so you can grant a subset of the access modes on a table, either to a list of users or to all or to a single user, and you can say with grant option. So I'll just explain the solution with a few examples. So here we're using bold italics to indicate grantable permissions. And so the marketing manager has been assigned to this role which has grantable permissions. So they're a potential grantor. And so over in the administrative part here, we have a role called grantor. And what that allows the marketing manager to do, and so this green thing over here is in the group graph, but we really haven't got anything else to show you about the group graph. If the marketing manager then wants to grant all their permissions, so these are all the SQL permissions here, on a table T to somebody else with grant option, well, all of those permissions are represented here by this role. So somehow I have to arrange for the assistant manager to be assigned to that role. And because they're also getting grant option, okay, all of that stuff is currently represented by the role assignments of the marketing manager. And so in the group graph, we just assign the assistant manager to be a subgroup of the marketing manager, and then they're also assigned to the grantor role, and so they have all those permissions with grant option. Okay? So that's one easy solution. If you're going to assign a subset of the permissions, then because you're so what we do in the construction is that any role with grantable permissions is made a domain ID. So we create a domain for that. And then what the person assigned to this can do is they can create a subrole within the domain. Okay? And so they create a role with precisely the right permissions. And it says with grant options, so they've got the grantable flag turned on. And we assign the user to that role and also to the grantor role because they have the grant option. And then if you're going to assign regular permissions, just insert and select on table T to Sue, then the subrole you create has regular permissions and you assign Sue to it and she's not assigned to the grantor role. So to summarize then, to improve on our previous construction, you would look at the DAC system, create the parameterized owner role, the grantor role, in the administrative part of the role graph, assign all the owners to the owner role, make it, add an attribute to all the permissions so you can see whether or not they're grantable, create the roles as we did before, and any role that's got grantable permissions is made a domain ID. And when the grant statement is issued, if there isn't already a role with the right package of permissions, then you create one. And because you're assigned to an administrative role, you have administrative privileges over that domain that you've created. Well, what does this do with the complexity? Well, we end up possibly creating a role for every combination of permissions issued in a grant statement. So it's somewhat incomparable with the other construction. So it's a function of the amount of granting you've done rather than a function of the number of permissions. So it's different. Some of our work we talk about design time versus run time. So at design time you should be designing the graph. So if this is all done at design time, you don't really need to be using, anyway, DAC, maybe quite so much. Okay, so we've also done some work on delegation, and the only thing I'm going to talk about today is, so I'm originally a database person, so if we go back to the early 70s, we were confronted with database packages that were called network databases that had very bizarre semantics. and hierarchical databases, and which look a lot like XML databases, but nobody will say that. And relational databases were just coming on the scene, and it was a very confusing landscape. And then Peter Chen came along with the ER model, the entity relationship model. And if you use it as a reference model, suddenly you can explain all the differences between the three original kinds of databases, and it all became much more clear. Okay? And so when we started working on delegation, what do we mean by delegation? Delegation is that activity which occurs at runtime when a user can't perform all their tasks and have to assign all or some of it to another user. The term delegation is often used to talk about allowing another machine to do user authentication on your behalf, but we're not talking about it that way. And we're not talking about role design. So we're not talking about design time. We're talking about runtime when exceptions occur. Okay? And so you start doing the literature survey. And there are 50 or 100 papers that talk about delegation with roles. And it's a very confusing landscape. But then we look at our model and say, well, let's treat it as a reference model. So what kinds of things can we be talking about? So the original role graph model has 5 main pieces to it. On the left, starting from the left, we have the relationships in the group graph, which I didn't actually explain, but the edges there mean that one of the thing at the tail of the edge is a proper subset of the group at the head of the edge. Group user role assignment, we have the role relationships in the role graph. We have privilege role assignments, and we have the privilege structure. And then we have sessions, which we didn't originally think about. So really 6 things to look at. And each of these can help explain what's going on in some of these very confusing papers about delegation. So when you do delegation, how do the role relationships come in? Well, you may have to create a role with precisely the privileges that you want to delegate. If you don't want to delegate everything that you have, you're creating a sub-role. Does it go in the role graph? Then it's, deals with the role relationships. You can talk about what gets delegated as a function of the privileges that a user can perform. And so that has to do with the privilege role assignment relationship. The privilege structure comes up in funny ways. So you can just flag a privilege as delegatable or non-delegatable. And I read one paper about people were talking about HTML actually, and so you could give permissions to somebody to update a piece of a web page. So what you have here is a hierarchical structure, right? It's like an XML document, and you're giving the permission on a sub portion of that object, and so you're not delegating the permission you have on the whole object. You're delegating part of the object, so it deals with the object structure. The most interesting one is the user role assignment. So people talk about role delegation, but what do they really mean? They're really saying that the users assigned to role 1 can be delegated to another role. Well, it has nothing to do with role 1. It has to do with the users. And it's really the user role assignment that's determining the delegatees, right? And so the proper way to think about it is that it's a function of user role assignment, not a function of role relationships. So you can use the information on the group graph as well to talk about only certain groups can be delegatees. So maybe you have accountants. You only want accountants to be delegated. And sessions, so the grantable privileges can be determined by your active roles. So what's happening in the present? RBAC is in a lot of products in some version or another. It's in a lot of these big things that manage a lot of applications together, like Tivoli, and I found something on a web page last week where there's something from Cisco that has roles. Ruby on Rails has roles. Roles are everywhere. how useful is it? So suppose you're in a company that can't afford Tivoli or doesn't really need Tivoli because you're not that big, and you want to use roles to manage one of your applications. Okay? So maybe you do have some software that uses roles. Maybe you have Oracle, but the roles provided by Oracle are fairly primitive, and that's not, you need something fancier. Again, going back to databases, early on in the 60s, one of the things that happened was that data schemas were buried in COBOL programs, and one of the big things was moving them out of the COBOL programs into something else, which eventually became a database, so that you could share the data. So why wouldn't you share your role design among more than one application? And so we came up with this architecture. So the idea is that use your favorite RBAC model, design your RBAC system. So it could be an ANSI thing, it could be ours. Get happy with your role design. Write it out in a secure place in some format, probably XML. And then if you look at all the operations that you're going to use from the application program, it's probably just all the getter methods. Does this person have this privilege? Okay. And so produce a runtime thing that can be attached to all your programs, and it interprets the same role design in more than one application. So this was something we did recently. Okay, so I'm running out of time, so I'll speed up a little bit. Will it really scale up? What's the right granularity? So should you be applying roles at the application level, at least as allowed to use the accounting application, or it should be that within the accounting application, at least is allowed to look at row D, column 45, you know, and update it. So what's the right granularity? If you get too small, the designs become so complex that you can't understand them. So you need a happy medium. There's still quite a bit of discussion going on about how to engineer your roles, whether you should do it top down or bottom up. I think if you have a lot of tools that let you see the consequences of what you're doing and get lots of feedback, it doesn't matter a whole lot which version of RBAC you use. It can still be useful. So my suggestion is use it as a design tool. So the ER model eventually became a design tool. There weren't really any commercial databases that I ever knew about that used the ER model. People used it as a design tool. Separate the design from the implementation. So if you have an RBAC design for your access control and implement it with policies, with some policy language, you know, why not? So I think we need good tools, good implementations, and good interfaces with various pieces of software. Okay, so here's some references, and thank you very much for coming. Yeah.
Okay, so then I think I don't have others. Okay,
Okay.
thank you then.
Thank you. I'll leave this up for a minute.